Imagine life that laughs at a desert sun, that shrugs off boiling heat, withers in drought, and then springs back to life with a drop of water. Imagine organisms that survive in space, in deep sea vents, in frozen tundra, and also in your backyard moss. These are extremophiles, and among them, tardigrades, water bears, are among the most extraordinary. The BBC Future article titled, "Harnessing the Superpowers of the Most Resilient Life Form on Earth" invites us into the world of these microscopic marvels. But their story isn't just fascinating. It has lessons for climate resilience, medicine, biotechnology, and perhaps for the very sustainability of life on Earth. Tardigrades are tiny, mostly less than a millimeter, but they have survived conditions that would kill most life instantly. Extreme temperatures, near absolute zero or above boiling, exposure to intense ultraviolet or ionizing radiation, desiccation, drying out completely, even the vacuum of space. They do this via cryptobiosis, a reversible suspended animation-like state. Their metabolism nearly stops. They protect their internal structures with special proteins and sugars. Their cells essentially glass over to prevent damage. When conditions improve, they rehydrate, reactivate, and carry on. Around the world, scientists are looking at extremophiles' superpowers as inspiration for solving human problems. In biotechnology, researchers are studying tardigrade-specific proteins, intrinsically disordered proteins, heat shock proteins, small protective proteins, to stabilize vaccines, enzymes, and biologicals without needing cold-chain refrigeration. This could revolutionize medical supply chains, especially in hot or remote regions. In agriculture, climate-resilient microbes, some inspired by extremophiles, are being used to help crops tolerating drought, salinity, heat. For example, plant growth-promoting bacteria or fungi are being explored in Asia, Africa, and Latin America to improve yield under harsh stress. There's also innovation in seed coatings. Inspired by tardigrades' ability to preserve themselves in dry states, some startups are developing seed coatings or microbe-embedded coatings that survive drying, heat, and transport, then activate upon planting. This helps in places without ideal storage or cold conditions. In space science and astrobiology, tardigrades are studied as models to understand how life might persist beyond Earth. Their survival in extreme radiation or near vacuum makes them prime candidates in experiments related to planetary protection, life detection, and even bioengineering for human space travel. Furthermore, gene editing tools like CRISPR are being used to probe tardigrade genes to understand which genetic mechanisms confer resilience and whether they can be adapted or mimicked for human or agricultural use. For example, DIPA CRISPR was used to modify specific genes in Rhizostomia variornatus to study dehydration tolerance traits. Why this matters globally: the Earth is warming, weather is growing more extreme, droughts and floods are more frequent. Many parts of the world, from sub-Saharan Africa to South Asia to arid parts of the Americas, face growing challenges in preserving agriculture, medical services, infrastructure, and ecosystems under stress. Let's take a few data points. Heat waves are driving crop failures in India, Pakistan, and parts of Africa. High temperatures reduce crop yields by up to 30% in some staple crops. Many vaccine cold chains fail in remote areas because of electricity disruptions or lack of infrastructure. Losses during storage or transport due to spoilage are significant in tropical, rural regions. Climate-resilient crops or technologies that work under heat, drought, or salinity are essential. Microbes or proteins that can make enzymes stable under such conditions can help reduce waste, improve yields, and spread access to technology. These challenges are not speculative. They are already affecting lives. And this is where Extremophiles lessons offer real hope. Solutions built on resilience, stability, and adaptation. When we witness nature's resilience, there is a spiritual dimension. The Quran repeatedly calls on humanity to observe, to reflect, to learn from creation, especially in how it perseveres. In Surah Al-Shams, chapter 91, verse 4-5, the Quran says, "And by the soul and He who proportioned it and inspired it with discernment of its wickedness and its righteousness." Here is recognition that the soul has measure, balance, capacity to distinguish. Similarly, extremophile life shows nature's measure, balance under stress, built-in safeguards, endurance. Also, Surah Al-Baqarah, chapter 2, verse 164 says, "Indeed, in the creation of the heavens and the earth, the alternation of the night and the day, the great ships which sail through the sea with that which benefits people, and what Allah has sent down from the heavens of rain, giving life thereby to the earth after its lifelessness and dispersing therein every kind of moving creature, and His directing of the winds and the clouds controlled between the heaven and the earth are signs for a people who use reason." This verse invites reflection on signs, cycles, resilience, restoration. Extremophiles embody many such signs: life returning after desiccation, surviving against odds, thriving in cycles. They are living signs for people who use reason, for scientists, thinkers, and also for faith. But harnessing extremophiles is not without challenge or risk. Transferring resilience traits to crops or medicine requires care, unintended consequences, ecological impacts, biosafety concerns. CRISPR editing or embedding proteins might raise ethical, regulatory, and equity concerns. Who gets access? Who bears cost? Can fragile ecosystems be preserved? There is also the danger of arrogance, assuming human systems can mimic nature perfectly without harm. Extremophile pathways are not magic. They evolved in specific contexts and often trade-offs exist. For example, survival under extreme dehydration may mean slow growth. To realize the promise of these resilient life forms, some critical steps. 1. Strengthen research collaboration globally. Involve scientists from developing nations, share genetic data, build capacity so that resilience innovations are accessible to places that need them most. 2. Fund development of stability-improving biotechnologies, stabilizing vaccines, forging resilient crops, improving shelf life under hot remote conditions. 3. Ethical, regulatory frameworks to govern gene editing, biomaterials inspired by extremophiles, ensure safety and fairness. 4. Support innovation in biomimicry and resilient production, seed coatings, biopreservatives, ambient temperature storage methods, all inspired by extremophiles. 5. Educate and build awareness. Public, policymakers, investors need to understand that resilience is more than survival. It's sustainability, equity, preparedness. The superpowers of extremophiles like tardigrades, surviving the impossible, preserving life where life seems unthinkable, are not just curiosities. They are lessons. They are invitations to rethink how we respond to biological fragility. In medicine, in climate resilience, in global food systems. When nature shows us what is possible under stress, faith offers a moral framework to use knowledge responsibly, to protect life, and to act justly. In Surah Fusilat, chapter 41, verse 53, the Quran says, "We will show them our signs in the horizons and within themselves until it becomes clear to them that it is the truth. But is it not sufficient concerning your Lord that He is, over all things, a witness?" The horizons of science and inner horizons, our character, our ethics, both offer signs. And when understanding from both converge, innovation becomes not just powerful, but right. So yes, we can harness these superpowers, not for spectacle, not for prestige, but for survival, healing, and justice. The Extremophiles teach us resilience. Let us pair that with compassion. The world needs both.